students, in gravitation chapter today we'll study the motion that for free falling body. That means whatever the effect of gravitational force on free falling body or any body or object you are just falling upward, you are falling downward, or you are just throwing upward, right? So in this lecture we will discuss motion of objects under the influence of gravitational force of the earth. Gravitational force of the earth. Okay. So here, first thing, whatever you need to study, that is the free fall. Now, I'm just trying to draw one thing here. Suppose I have one object here, and this is the ground or earth surface, and this object will fall down, but none object, not any other force will be applied to the object, only there will be some gravitational force. Due to this gravitational force, this object will fall towards the ground or fall on the ground, right? So the gravitational force, due to this gravitational force, the earth, it attracts every object towards it. That's why the apple, whatever noticed by Sir Isaac Newton, it just fallen to this ground. And also, if you are just throwing one ball, after some time it will come to the earth surface, right? So when we just throw any ball or any object falls towards the earth, it happens due to the gravitational force. It will attract the object, and that's why you know that it will attract the object, so the object will fall on the earth. Now, when gravitational force will be acting, at that time, no other force will be acted on the object. If this condition happens, at that time we are calling this is the free fall motion. This is what? Free fall motion. Okay? And the object which is just falling down, at that time it is called free fall body or free fall body. The object is called free fall body. The motion of the object, that is called free fall motion. Okay, so this concept is very clear. This concept is very clear. Now, for the free fall motion, that means now whatever you have, that you have whatever the equation for the motion, already we know the final velocity, that is u plus at, and then the, just a minute, we have denoted by s. I'm just going to delete this one. Okay, so s equals to ut plus half at square, and also v square equals to u square plus 2as, right? These three are very well known equation of the motion. Now here, v is the final velocity, u is the initial velocity, a is the acceleration, t is the time, right? All these things already we have discussed. Now v is the final velocity, u is the initial velocity, but here the a, acceleration, this acceleration is similar to the g here, because it is a free fall motion. That means the object, it is not moving horizontally, it is not moving in any other way, it is just falling down, or the object you are throwing upward condition, right? So that a similar to g here. So if we do this thing, at that time we can write v equals to, I'm just deleting all this for the time being. So here whatever we have, v equals to u plus gt, where v is the final velocity, U is the initial velocity. G is the gravitational acceleration, and H is the height from which the object will fall, or up to which the object will move upward against the earth, right? This is the H. Okay, so already I have mentioned all the notations. V equals to U plus GT. Only in place of A you have to put G. H equals to UT plus half GT square. V square equals to U square plus 2G. Fine. So always remember one thing, is just we are replacing the acceleration A with the G for free fall motion. Now let's do some numerical here. I'm just changing the color of the pen. Okay. Let's solve this problem. A car falls off a ledge and drops to the ground in 0.5 seconds. Fine. G is the 10 meter per second square. Then first, that is the what is its speed on striking the ground. Okay, fine. First, we are just writing whatever the given data, that is time taken t, that equals to 0.5 second, and gravitational acceleration G has been given here, 10 meter per second square. So as the car is free fall, so initial speed or initial velocity, I can say in better way, that equals to 0. Let's solve the first one. In the first one, what they need, what is its speed on striking the ground? Fine. So under free fall, U equals to 0. Acceleration, that is G. So V equals to U plus GT. Now V equals to 0 plus GT, or V equals to GT, or V equals to 10 into 0.5, or V equals to 5 meter per second. Okay, so this is one answer. Fine. So A is complete. Now let's think about B. What is its average speed during 0.5 seconds? Now here average speed, that is the, let we denote with AV. Just a minute. Okay, AV. Okay, so this VAV, that equals to U plus V divided by 2. So that will be 0 plus 5 divided by 2. That means average speed will be 2.5 meter per second. So this is the second answer. Let's do the last one. How high is the ledge from the ground? So here for the C, U equals to 0. Let height, that is H. So H equals to UT plus half GT square. Now this will be 0. Half G is 10, T squared 0.5 square. So this will be 5 into 0.25. So this will be 1.25 second. So here, just a minute. Here, height will be this much meter. Okay. So this is the solution for C. Next, a stone is thrown vertically upward, right? So this is the stone. This is that stone. I have to throw it vertically upward. Fine. Passes a point P with its speed V. So let it be P point. Here speed is V. And point Q is 20 meter higher than P. Okay. Let it be Q. And it is 20 meter higher than this one. With its speed √5/3 into V. The value of that speed, that means V, I have to find out, right? So here, so this is very cute, no? So you are cute. So the velocity of object at P, that equals to V, and height difference, that equals to H, that equals to, let it be 20 meters. And velocity at Q, that equals to √5/3 into V. So we know that according to the third law of motion, V square equals to U square plus 2GS. So here √5/3, this V is the velocity at Q point. So I can write this is Q, and this is the velocity. This is the velocity at P point, right? So I can write down this is the V at P point. So this is the initial velocity because P is under this thing. So √5/3 into V whole square, that equals to V square plus 2 into 10. G has been given here 10 meter per second square into 20. So here 5V square by 9 minus V square, that equals to 400. So here you have, how much will be the value? That will be V equals to your 30 meter per second. Okay. If you find out from this equation, so you will get 30 meter per second. Okay. It is going upward. That's why some minus sign may come, but no need to worry. So this is V equals to 30 meter per second. Okay, fine. Another one, an object is thrown vertically upward and rises to a height of 10 meter. Rises to a height, what is the height amount? 10 meter. Calculate the velocity with which the object was thrown upward and the time taken by the object to reach the highest point. Let's solve this problem. Now distance traveled, this S is equal to 10 meter. Final velocity V equals to 0 meter per second. Okay. And acceleration, that G equals to 9.8 meter per second square. But here acceleration of object upward, we are considering minus 9.8 meter per second square, right? So first bit, that is v square equals to u square plus 2as. This formula we can use only if we have to change the acceleration here. So v is the 0, u square plus 2 into acceleration is minus 9.8, and here you have 10 meter. So from this equation, u will be 14 meter per second. This is one answer. And bit 2, that is v equals to u plus 80, where 0, 14 plus minus 9.8 into t. So t equals to 1.43 seconds, right? So both of the answers you can write here. Both of the answers you can write here. First answer is the u, that is the velocity with which the object was thrown upward is 14 meter per second. And second answer, this is answer 1. Second answer, that is the time taken by the object to reach the highest point is 1.43 seconds. 1.43 seconds. Okay. So you just see this numerical. If you have any doubt, so I will again repeat this one. So here, if upward at that time, one thing you remember, if upward movement of the object at that time, you may consider that upward movement g minus 9.8. For downward, we are using plus 9.8. But one thing you should remember, all of you should remember that if you are using any sign here, at that time, you can use minus 9.8 or plus g, minus g or plus g. It depends on yourself. But you have to mention that thing, like I have mentioned here. I have mentioned here upward, that is minus 9.8. So if you are considering downward minus 9.8, you have to mention this one, right? It is not a strict rule that always you have to take minus 9.8. Okay. Next, the mass. This term is very well known to us. Mass is the fundamental quantity of any object, and mass is the measure of amount of the matter in a body. And SI unit, that is the kilogram or kg. SI unit, that is the kilogram or kg. Just a minute, I have to change the color of the pen. Just changed. Okay. Kilogram. Okay. And mass of the body, it will not change at any time. Mass is always equal, but weight of the body or object, that may be variable. But mass is not changing at any time, but it has been seen that whenever some nuclear reaction we are doing, at that time, tiny amount of matter is converted into huge amount of energy. and that reduces the mass of the substance. At that time, nuclear reaction, at that time only we can say that yes, the mass has been changed a little bit, right? Now the weight. Weight is the measure of force of gravity acting on our body. Force of gravity acting on our body. Force of gravity acting on our body, right? And this formula of weight, that is m into g. And here g is the acceleration, gravitational acceleration, m is the mass. Just a minute, I'm writing the. So here m is the mass of body, g is the acceleration due to gravity, and the SI unit, that is the Newton. SI unit is the Newton. So here the difference between mass and weight has been described. Mass can never be zero. Weight can be zero. As space, if no gravity is there, what is the weight? M into G. If G equals to 0, at that time weight equals to 0, right? So in space, if no gravity acts upon the object, then weight may be 0. But mass is not dependent on any acceleration, any G. So this cannot be 0. Mass is scalar quantity and it has magnitude. Weight is a vector quantity. Like if you are moving downward or if you are moving upward, and how much distance you have gone upward or how much distance you have covered for downward condition, downward motion, at that time, that means your acceleration, that will be different. So weight is a vector quantity. It has the magnitude, also is directed toward the center of the earth or other gravity well. Mass is commonly measured in kilogram or grams, and weight always in Newton. Weight varies according to location. Okay, that means some object if you have in the moon, at that time what will be the weight? Some object you have in another planet, what will be the weight? That depends on the gravitational acceleration of that planet or that moon, right? So mass does not change according to the location. And the mass may be measured using an ordinary balance. Like you can see whenever you are going to market, they are just taking some ordinary balance. At that time, they are just measuring this. But weight can be measured using the spring balance. Okay. Now, relationship between mass and weight. Now, relationship between mass and weight, that the relation between weight and mass of the object with 1 kg mass will have the weight 9.8 Newton, because F equals to M into G. So if you have 1 kg and G is the 9.8, so 9.8 meter per second square, that means F equals to how much? Actually 9.8 Newton. So this is the main relationship between the mass and the weight. Mass and the weight. Thank you.